Hello everyone, and welcome back to UCram We Teach, and today we're going to be talking about the properties of matter and what they are, as well as physical and chemical changes. So let's hop straight to it right after our intro.
Page by page, one day before a test or quiz, we've got you. You'll be instead you're fighting, braving the elements, Mendeleev, genetics, SOHCAHTOA, feel the power. You'll be a procrastinator, studying till the last minute. All you gotta do is cram, pulling all-nighters just to give it your best shot. You cram and we'll teach, you cram and we'll do the rest.
I'm sure we've all wondered at some point, what happens when we cut butter? What stays the same and what stays different? Obviously the size will change, but other than that, what changes and what stays the same? Let's find out today. So now we want to answer our butter question, but in order to do that, first we need to say what matter is, because we're talking about the properties of matter, right? So according to Merriam-Webster Dictionary, matter is a material substance that occupies space, has mass, and is composed predominantly of atoms consisting of protons, neutrons, and electrons that constitutes the observable universe and that is interconvertible with energy. Basically, what this is saying is that matter is defined as anything that has mass and takes up space. It's made up of atoms and is in the observable universe. So, today we're going to talk about two distinct types of properties of matter, physical and chemical. But wait, you might be asking, what are properties? Well, I'm glad you asked. Properties are something that can be defined as something that differentiates one bit of matter from other bits of matter. They're what differentiates me from this backdrop over here. So let's start off with physical properties, shall we? So physical properties are something that can be observed or measured without changing the composition of the matter. Physical properties are used to observe matter, to describe it. And physical properties can be further boiled down into two sections, because of course it can. We have intensive and extensive property. Well, what's the difference between the two? The difference is present in how much of the matter you have. Or well, whether or not you have a lot of matter or you don't. So basically, intensive property is something that doesn't depend on how much matter you have. It says, okay, so if I have this large block of coal over here and this small block of coal over here, they're going to be pretty much the same properties. They will be the same properties like density, malleability. Those are two examples of it. Meanwhile, for extensive properties, there's something that's dependent on how much matter we actually have. So these are going to be like volume and length and height. Now, let's recap. Recap time. Intensive properties, a physical property that will be the same, regardless of how much matter we have. Density, color, conductivity, which is the ability for electricity to flow through a substance, malleability, if something can be flattened, luster, how shiny something looks, are all examples of intensive properties. Meanwhile, for extensive properties, these are a physical property that will change depending on how much matter we have. And these are examples like mass, volume, height, and length. Now, let's move on to chemical properties. Now let's discuss chemical properties of matter. So, what are chemical properties? Basically, chemical properties are something that have the potential to undergo some chemical change or reaction. I'm going to get into chemical changes in just a moment. So, basically, it's something, if you have the ability to change a substance, that's going to be a property that's chemical. So, hydrogen being able to ignite and explode is going to be a chemical property. Zinc or any type of metal reacting with hydrogen or oxygen and having something happen, that can be chemical. Now, let's recap. Basically, if something has the ability to undergo a change, if a substance has the ability to undergo a change, then it can be altering the composition of the matter. It has the potential to do that. It's going to be a chemical change. For example, hydrogen igniting is going to be a chemical property. Now, let's move on to physical and chemical changes. Alright, now let's talk about physical changes. So, a physical change is something that takes place without any changes in the composition of the substance. So basically, if the same element or the same compound is present before and after the change, it's going to be a physical change. Meanwhile, a chemical change is something that alters the substance from the original substance. Basically, if different elements or compounds are present at the end rather than the beginning elements or compounds, the chemical change has occurred. And basically, how this happens is that the atoms and compounds are rearranged to make new and different compounds. So let's recap. A physical change is something that has the ability to change the substance, but the same composition is going to be there at the end and the beginning of the change. Meanwhile, for a chemical change, the substance is going to be altered from the beginning substance, and that is how you can tell the difference between a physical and a chemical change. Now, let's have a grand recap, and then we can go on to some practice problems. Alright, grand recap time. So let's start with properties of matter. And this is how we can easily identify physical or chemical properties. We want to ask this one question. Are the properties determined without changing the basic identity of the substance? If yes, it's going to be a physical property. But if no, it's going to be a chemical property. So let's start with chemical properties. And chemical properties are basically going to be how the substance reacts to X, Y, or Z. So let's give an example of water. If that substance reacts poorly with water, that's going to be a chemical property. Or if it ignites when exposed to air, that's also going to be a chemical property. Now, moving on to physical properties, we have a further question that we ask. Does it depend on how much matter we have? If yes, it's going to be an extensive property like mass, volume, or length. But if not, that's going to be an intensive property, and it's going to be like color, boiling point, density, malleability. Those are all going to be examples of intensive properties. Now, for changes, I've already covered this in a previous recap, but for a physical change, if we had the same composition before and after, it's going to be a physical change. But in a chemical change, if we have the beginning substance and the end substance being different, it's going to be chemical. Alright, now we've gained all the knowledge, but we need to answer our butter question. When we do cut a slice of butter, what changes about the butter? Well, as we discussed, length, volume, height, width, length are all going to change because those are extensive physical properties. Meanwhile, the density of butter is going to stay the same because that doesn't depend on how much butter we actually have. The chemical properties of butter also aren't going to change because butter is still going to be butter. If it goes under extreme heat, it's still going to be butter. And for any chemical properties, if butter is for some reason flammable, it's still going to be flammable because even if you cut off a piece of butter, it's going to be a physical change. So it only impacts those extensive physical properties. So I hope that answers our burning question of what happens when we cut butter. Thank you, and let's move on straight to the practice problems. Alright, now we're going to do some practice problems. I'm going to give you a few seconds in between saying the question and the answer, so you can pause or you can answer in that time. Alright, question number 1. Is this backdrop behind me made of matter? Yes, it is, because it takes up both space and has mass. Alright, question number 2. Is volume an intensive physical property or an extensive physical property? Yeah, it's going to be an extensive physical property because it changes based on how much matter or how much of a sample you have. 3. Is iron rusting a physical change or a chemical change? It's going to be a chemical change because it's going to be a new kind of matter or new composition at the end. 4. Is water melting a physical change or a chemical change? It's going to be a physical change because it's going to be the same composition at the end. Is density a chemical property or a physical property? It's a physical property because it can be observed about the piece of matter. And final question, is hydrogen being flammable a chemical property or a physical property? It's going to be a chemical property because it depends on whether or not the substance can be changed. That's what makes it a chemical property. Alright, thank you for being with us and thank you for watching this episode of Parth Talks. Fortunately, this is going to be one of our last solo videos. Pretty soon Shoria will be joining me. So thank you for being with us and I hope you learned something today. Thank you and I hope to see you next time. Goodbye. So, first off, we have intensive and extensive. Oh, I got ahead of myself now, didn't I? Whoops. Whoops, that's a blooper. And my computer went to sleep in the middle of that. Like, that's annoying. Parth. Not all Parth, you might be asking, because I'm the one who's teaching. Why does English not make sense? Why does it be so filled with bloopers? Well, Sharia, I hope you have fun editing this. I think I've said that before, but I'm not telling you which one you... Did I just mess up a good take? I feel like I did. Occupied space has mass that is composed for that is composed for that. That is composed for that.